Welcome to All This Math. This is Professor Parker, and today we're doing some work with transversals and parallel lines. All right, so we're going to jump into some geometry. We have a transversal right here, right? And we have two parallel lines, right here and right here. Now, how do I know that those are parallel lines? This is how I know that those are parallel lines. Because these arrows that are drawn or like superimposed on the lines, right? But not at the ends, right? These are arrowheads that are at the ends, which signify that these are actually lines, meaning that they go on forever and ever in both directions. But the fact that these two lines are parallel are due to this symbol right here and this symbol right there. All right, so that's important because we need to know what we're looking at. We need to know the information about what we're looking at. Now, what are our instructions though? Check this out. Find x and find the angle measure. All right, so I say this all the time. Geometry is just algebra 1 with shapes. That's basically all geometry is. That's why we need to have a solid foundation in algebra 1 in order to really attack and understand and solve geometry problems. All right, now, what do I know from geometry that will enable me to create an equation? Because in geometry, we need to be able to look at a shape, look at an angle, look at a line, look at a ray, look at whatever, and then create an equation. And then once you create the equation, write the equation down and then solve the equation. All right, and that's how we solve our problem. Now, I see a transversal and I see two parallel lines. And I also see these two angles, one here and one here. And I see that these angles are represented by their own expressions. First thing I want to think about is, how are those angles related? And do they have a relationship at all, right? They do have a relationship. These angles are called alternate interior angles. Alternate interior angles. Now, why are they alternate interior angles? They're alternate interior angles because this is the transversal. This angle is on the right side of the transversal, and this angle is on the left side of the transversal. So these angles are on alternate sides of the transversal. The angles are on alternate sides of the transversal. Now, they're interior angles because if you check out where these parallel lines are in relation to the angles are like in between the two parallel lines, right? This angle is above this parallel line, and this angle is below this parallel line. So these two angles are in between the two parallel lines, as opposed to being exterior, which would be up here, either here or here, and down here, here and here. So that's why these are alternate interior angles. All right. So I know they're alternate interior angles, right? So alternate interior angles. But then I say, okay, well, how does that help me? I know something about alternate interior angles. I know that alternate interior angles are congruent. What does congruent mean? Congruent means that they have the same measurement. So then I can use that information to create my equation, right? Because alternate interior angles are congruent. So that means that this angle has the same measurement as this angle right here. So from that information, I can create an equation. Whatever the measure of this angle is equal to the measure of this angle. Now, I don't know the measure of this angle, the exact measure of this angle numerically, but I know this expression right here represents the measure of that angle. I know this expression right here represents the measure of that angle. So that's how I set up my equation. I'm going to say 12x minus 3, because that's the measure of that angle, what it's represented by, is equal to 10x plus 15, because these angles are equal to each other, right? If these angles are equal to each other, and then we have this expression represents that angle, and this expression represents that angle, then that means these expressions got to be equal to each other. So 12x minus 3 is equal to 10x plus 15. All right? Now, at this point, I tell my students this too. And they know this. Ask them. Ask any of them from the years past. Once you get to this point, the geometry is really over for real, for real. Now you're just doing algebra. The geometry is really over. Now you're back in algebra 1 now. And we got to solve for x. All right? So what I would do is I would transpose. There are many ways to approach this equation. I like to transpose. That's just me. Meaning I like to just take terms and move them from one side of the equation to the other so the equation can be more organized, and then I can combine like terms. I want to be able to combine like terms because I got too many x's. I want to have one single x term. But right now I got 1, 2. And I got two constant terms, -3 and 15. I want one single constant term and one single x term. So watch what I do. I'm going to move this 10x over here. I'm going to move this -3 over here. But when I switch the side, I got to change the sign. When I switch the side, I got to change the sign. So watch this. This 12x was already over here, so it stays the same. The 10x moves over to the left. It's not positive no more. It used to be positive. But when I slide it over to the other side, it becomes negative. So now it becomes minus 10x. Remember that. Switch the side, change the sign. Pause the video and write that down. Switch the side, change the sign. All right? So 12x minus 10x is equal to, and then I'm going to slide the -3 over. That's going to become +3 plus 15, right? Now, I could have put the 15 before the 3 or the 3 before the 15. It doesn't make a difference, right? All I care about is that I have this like terms on the same side, so that way I can combine them. Now I have 12x minus 10x, which gives me 2x, because that's 12 minus 10, which is 2. And then over here, I got 3 plus 15, which is 18. Now I'm almost done. Almost done, right? We're about to get to the finish line. Now, 2x equals 18. How do I get x by itself? I get rid of the 2. How do I get rid of the 2, though? You do the opposite operation. You do the opposite operation from what the 2 and the x are doing. The 2 and the x are multiplying. So the opposite of multiplication is division. Divide by 2 on the left, divide by 2 on the right. 2 divided by 2 is 1. 1x is just x. Over here, 18 divided by 2 is 9. We know our division facts as long as we know our multiplication facts. So those of y'all out there that don't know all your multiplication facts, at least from 1 times 1 up to 12 times 12, memorize those ASAP. I guarantee it'll make life in math classes a lot easier. Memorize those ASAP. All right, so x is 9. But we're not done, though, because the second question or the second set of instructions is to find the angle measure. So find the angle measure. I know what x is, but remember, the angle measure is represented by 12x minus 3. So watch what I do. I want to find out this angle measure. So if I know that that's 12x minus 3, then I know x is 9. So I know I can just substitute or basically evaluate this expression for x equals 9, which basically just means plug in 9 where the x is and then do the math. So that's going to be 12 times 9 minus 3. Now what's 12 times 9? That's 90 and that's 18. 90 plus 18 is 108. Yeah, cool. So that's 108 minus 3. And remember, order of operations. You should not be doing 9 minus 3 first and get 6 and then multiply that by 12. You should not be doing it. That is not the order of operations. That's not what we do over here. All right? Follow the order of operations. Multiply first, then you subtract. Multiply first, then you subtract. I tell people all the time, math is easy if you know the rules. Math is all about rules. You learn the rules, you learn when to apply the rules, and you learn how to apply the rules, right? If you can do that, if you can think of math in that context as just a whole bunch of rules that you have to memorize and know how to apply in the appropriate situation, then math will become easy. But somebody has to teach you the rules, though. If you don't get taught the rules, it's going to be real difficult because you'll be out there on your own, like not knowing what to do because you didn't learn the rules. But if you learn the rules, then math becomes easy. Like right now, the rule is, or my instructions are, to subtract because that's a subtraction sign. So 108 minus 3 is 105. So that means that this is 105 degrees. Now, I could do the same thing for 10x plus 15. I could do that. But do I need to, though? We got to always use critical thinking and try to work smarter and not harder. Do I need to do that? I don't need to do that because what did we say from the rip? From the beginning, we said that alternate and interior angles are congruent. So dig it. If I know that this is 105, what's that got to be? That's got to be 105 too. But if I'm going to check my work just to be sure, okay, cool. I could throw the x in there. I could throw the 9 in there for x. 10 times 9 is 90. And 90 plus 15 is 105. So that's proof. All right. So x was 9. And the angle measures are 105 each because they're alternate interior angles. And alternate interior angles are congruent. All right. So please, if you like the video, like it, subscribe to the page, tell some people about it, share the page. Anybody that's taking geometry, even if you're not taking geometry yet, you don't got to wait for your geometry class to learn geometry. You can come to the All This Math channel and learn all the math you want. We out here. All right? So, do remember that there's all this math all around you. Peace.